Good morning. I am Dr. Hepsi. I am going to explain about gravitation. Kepler's laws of planetary motion. Each planet revolves around the sun in elliptical orbits with the sun at one focus of the ellipse. In the diagram, P represents the planet, S represents the sun, A and B are the semi-minor axes. The second law of Kepler's law is the radius vector drawn from the sun to the planet sweeps out equal areas in equal intervals of time. The areal velocity of the radius vector is constant. If the planet moves from A to B, C to D, and E to F in equal interval del t, then the areas ASB, CST, and ESF are equal. When the planet is nearest to the sun, its velocity is maximum. When the planet is farthest from the sun, its velocity is minimum. The third law represents the square of the period of revolution of the planet from the sun is proportional to the cube of the semi-major axis of the ellipse. That is, t squared is proportional to a cube. From this law, it follows that larger is the distance of the planet from the sun, larger will be the period of revolution. The planet Pluto is farthest to the sun. Its period is 248 years. Newton's laws of gravitation. Every particle of matter in the universe attracts every other particle with a force which is directly proportional to the product of their masses and inversely proportional to the square of the distance between them. Let m1 and m2 be the two masses of particles situated at a distance r apart. The force of attraction between them is given by F is proportional to m1 m2 divided by r squared, or F is equal to g m1 m2 divided by r squared. Here g is a universal gravitation constant. Mass and density of Earth. The force of attraction of the Earth on a body of mass m placed on it is equal to m into g. Here g is an acceleration due to gravity. M is the mass of the Earth or radius of the Earth. Gravitational force of attraction between a body of mass m and Earth is equal to g m divided by r squared. So we can equate both the equations. G mm by r squared equal to m into g. Mass and density of Earth. M is equal to g r squared by g. The density of Earth is given by rho is equal to m by v. So rho is equal to g r squared by g divided by 4 pi 3 pi r cube. That is equal to 3g divided by 4 pi rg. Determination of G-Boy's method. Apparatus. A small mirror strip RS is suspended from a torsion head H by means of a quartz fiber W. From two ends of the mirror, two identical gold spheres A and B are suspended. The two spheres are arranged to be at different levels. The arrangement is enclosed in a fixed inner tube T1. In the outer coaxial tube T2, two large lead spheres C and D are suspended. The center of C is in level with that of A, the center of D is in level with that of B, and the distance AC equal to BD. The outer tube is rotated so that the larger spheres are on the opposite sides of the smaller spheres. Gravitational attraction between the two pairs of masses produces a torque on the mirror strip RS. Due to this torque, the mirror is deflected through an angle theta. The deflection theta is measured by a scale and telescope arrangement. Calculation. M represents the mass of the lead sphere. Small m represents the mass of gold sphere. D represents the distance between the spheres. Force of attraction between the sphere A and C is G mm divided by D squared. Similarly, the force of attraction between the spheres B and D is equal to gmm divided by d square. Hence, two equal, unlike parallel forces, act at R and S. Let I be the mirror strip RS, length of the mirror strip. The deflecting torque is given by gmm divided by d squared into L. The restoring torque is set up in the suspension fiber. Let C be the torque per unit twist. Then for a deflection theta, the restoring torque on the fiber is equal to C into theta. When the system is in equilibrium, the two torques must balance each other. So gmm divided by d squared into L is equal to C into theta. So G equal to C theta d squared by M, capital M, into L. Using this arrangement on the quartz fiber and the mirror strip with gold spheres as torsion pendulum, the period T is found. Then T is equal to 2 pi into square root of I by C. Here I represents the moment of inertia of the suspended system. From this, C can be calculated. Substituting for C in equation 1, G can be calculated. Merits of Bayes method. The use of quartz fiber makes the apparatus very sensitive and accurate. By the scale and telescope arrangement, very small deflections can be measured accurately. The two pairs of spheres are suspended at different levels. So, cross attraction between the pairs of spheres is eliminated. Thank you.